Okay, so this one I decided to mix it up a little bit. So you're going to want to copy this down, and you don't need to adjust your frame at all. This is in radians. So this is just like degrees. So these are just in radian measure. So around the unit circle, remember that pi over 2 is 90, pi is 180, 3 pi over 2 is 270, 2 pi is 360. And then, of course, we have another rotation going around in terms of pi. And you can see how they go up in increments of pi over 2. So this is 1 pi over 2, then pi. Then 3 pi over 2, 2 pi. 5 pi over 2, 3 pi. 7 pi over 2, 4 pi. So you could continue this pattern all the way up. These are all odd pi over 2s. And these are all whole pi's. Over here, these are negative, which means that we would be going a clockwise rotation. So I thought maybe radians would be good to see as well, just because you're going to see them either way. So this is 0 pi radians, and then we're going to have pi over 2, then pi, then 3 pi over 2, and then 2 pi. This is what's going to be in your table. And remember that cosine takes the x values. So at 0 is 1, at pi over 2 is 0. At pi is -1, at 3 pi over 2 is 0, and at 2 pi we're back at 1. And that represents one full rotation. So when I go to graph this one, I'm showing you that it's periodic. At 0, we're going to go up to 1. So it doesn't start at 0, 0. It starts at 1 here. And then it falls to 0, goes down to -1, back to 0, back to +1. And remember that this, oops, did I go a little too far? I think I did. Good grief. This is not a V, okay? This is a wonderful curve that looks like a U. And then what will happen is if we complete another rotation, we would go back to, this would be 5 pi over 2, which is at 0. And then at 3 pi, this is 2 pi, this would be 3 pi, would be at -1. Then 7 pi over 2 would be at 0. And 4 pi would be back up at 1. So watch this. So you can see it's periodic because the cycle repeats itself. Now, when we got to go this way, we're literally just going clockwise. So we're started at 0, which is at 1. At -pi over 2, we would go to 0. -pi, we'd be at -1. -3 pi over 2, we'd be at 0. And at -2 pi, we're back up at 1. So this literally looks like that. So again, when we're looking at this periodic function, you're going to see that the amount of time it takes to get one full rotation in radians from start to finish is 2 pi time. This is 2 pi. This distance in radians. The one up here is 360 degrees. One full rotation. That's a period. The amplitude is your max minus your min divided by 2. Our max is 1. Our min is -1. And that's going to give us 2 over 2, which is 1 again. So our amplitude is 1. The distance from our first to second point is 1 unit. Range. Our range is from lowest to highest value. So our lowest value is -1. Highest value is 1. And you can write it like this as well. Just interval notation. You can write it like that. Instead of this notation, you can use interval. And domain, we're going from 0 to 2 pi for one rotation. for one rotation. But this is periodic, which means that technically your domain is negative infinity to infinity, because this can go on and on and on and on forever. So this is for one rotation. But negative infinity to positive infinity for the whole function. This is just for one rotation. This is for the whole function. The same thing goes above. So we might want to clarify that a little bit. So from 0 to 360, this is going to be for one rotation. But negative infinity to infinity for the whole function. All right, so the technical domain is negative infinity to infinity because it can go on forever and ever in both directions, like waves do. But if we're looking for just one rotation, it would be from 0 to 360. One rotation would be from 0 to 2 pi. All right. Now, radians isn't just for cosine and degrees only for sine. Like, I'm showing you that these could work for either of them, just so that you know. All righty. And we're done with this.